What if the strangest thing inside 3I Atlas is not its shape, not its speed, but its chemistry? You clicked because you want to know what scientists actually found inside this interstellar object, and whether it is just unusual or something much bigger. The answer comes down to two discoveries: an extreme amount of deuterium and a surprisingly high level of methanol. And once you see why those two chemicals matter, you will understand why scientists think 3I Atlas may have formed in a place completely unlike our solar system. And these are not just random chemistry details. For scientists, these two discoveries matter because they help answer the biggest question about 3I Atlas. Where did it come from? When astronomers cannot crack open an object and bring it into a lab, chemistry becomes their best tool. Chemistry is how they read the object's history from a distance. And right now, the chemistry of 3I Atlas is telling them this object did not form in a place like our solar system. Subscribe to Space Aquarius and let's begin. You already know what 3I Atlas is? It is the third confirmed interstellar object ever detected passing through our solar system. It came from another star system, and it is only here for a short time before heading back out into interstellar space. That alone makes it rare. But what makes it scientifically valuable is not just that it came from somewhere else. It is that it may be carrying a preserved chemical record of that somewhere else. If somebody hands you a rock from another country, you can look at it and say, "Interesting rock." But if you analyze the minerals, the isotopes, the trapped gases, and the organic compounds inside it, suddenly that rock becomes a witness. It starts telling you where it formed, what environment shaped it, how cold or warm it was, and what kind of material it was surrounded by. That is exactly how scientists are treating 3I Atlas. And two of the strongest clues so far are methanol and deuterium. Let's start with deuterium, because this is the bigger deal scientifically. Hydrogen is the simplest element in the universe: one proton, one electron. Deuterium is a heavier version of hydrogen. It still has one proton, but it also has a neutron. Same basic chemistry, but a little more mass. Now here is why that matters. In very cold environments, certain chemical reactions tend to favor deuterium more than ordinary hydrogen. So when astronomers measure a high deuterium to hydrogen ratio, that can be a sign that the molecule formed in an extremely cold place. That is why scientists pay so much attention to it. It is not just an odd number, it is a temperature clue and an origin clue. And when researchers looked at 3I Atlas, the deuterium levels came back shockingly high. According to one of the web-based studies discussed by Avi Loeb, the water around 3I Atlas showed a deuterium to hydrogen ratio of about 0.95%. That is more than 10 times higher than what has been measured in known comets. Then another paper looked at methane released by 3I Atlas and found a deuterium to hydrogen ratio of about 3.31%. That is even more dramatic. Loeb says this methane value is 3 orders of magnitude higher than methane found on planets in our solar system, and far above what is seen in comets or meteorites. So why does that matter so much? Because now scientists have the same strange signal showing up in more than one molecule. It is not just the water being weird, it is the methane too. That makes it much harder to dismiss as noise, contamination, or a one-off measurement problem. It starts to look like a real chemical pattern, one pointing to formation in a place that was extremely cold, possibly below about 30 degrees Kelvin. And that is important because our solar system does not usually produce this kind of chemistry in the objects we know best. So when scientists see this much deuterium, they start thinking, maybe 3I Atlas formed in a very different kind of protoplanetary disk, around a different kind of star, or much earlier in galactic history than our solar system did? That is the first big reason deuterium matters. It may tell us that 3I Atlas is not just from another star system. It may be from a very ancient and very unfamiliar one. Now let's talk about methanol. Methanol is a simple organic molecule, CH3OH. It is not life, it is not proof of biology. But in space, methanol matters because it forms and survives best in cold, icy environments, especially on dust grains coated with frozen material. That makes it another excellent environmental clue. A team using ALMA in Chile measured chemicals in the coma of 3I Atlas and found methanol along with hydrogen cyanide, or HCN. The surprise was not that methanol was there. The surprise was how much of it there was compared with HCN. They found methanol to HCN ratios of about 70 on one date and about 120 on another. That is unusually high, much higher than what scientists typically see in comets from our own solar system. And again, that matters because chemistry is comparative. Scientists are always asking, compared with what? Compared with solar system comets, 3I Atlas appears to be loaded with methanol. That tells scientists two things. First, it likely formed under chemical conditions very different from the ones that made most of our comets. Second, 3I Atlas may preserve a richer record of organic chemistry than expected. And there is one more part of the methanol story that makes this even more interesting. The ALMA data suggests the methanol is not only coming from the nucleus of the object, it also appears to be coming from ice particles in the coma around it. That means methanol is not just sitting in one spot. It may be spread throughout the material of 3I Atlas, and also stored in small icy grains surrounding it. As those grains warm up near the sun, they release their methanol. That is important because it suggests methanol is not just a surface detail. It may be built into the object's structure more deeply. So now put the two anomalies together. Extreme deuterium says this object likely formed in a very cold and unusual environment. High methanol says this object may be rich in cold-formed organic chemistry, unlike what we usually see in our own comet population. And when both of those clues show up in the same object, scientists start thinking bigger. This is no longer just a rare visitor. It may be a preserved sample of a part of the galaxy we have never studied directly. That is why these findings matter so much. They are not just interesting chemicals. They are some of the best evidence we have so far that 3I Atlas formed under conditions very different from those that shaped our solar system. Now add one more layer, the isotope work on carbon in 3I Atlas also came back unusual. According to the March 2026 results, the 12C/13C ratios in carbon dioxide and carbon monoxide were higher than the values typically found in the solar system, nearby interstellar clouds, and protoplanetary disks. That pushes the same basic message again. This object is chemically out of family with the material around us. That is why some researchers interpret 3I Atlas as a fragment from an ancient planetary system, possibly formed 10 to 12 billion years ago. If that is right, this object is not just foreign in space, it is foreign in time. It would be far older than Earth, far older than the Sun, and old enough to preserve chemistry from an early chapter of the Milky Way. Now, to be fair, not every scientist agrees on exactly what that means, and Avi Loeb has argued that explaining 3I Atlas as a product of old, metal-poor stars creates a serious mass budget problem. In simple terms, he thinks those kinds of stars may not have had enough heavy material to make enough objects like this. That does not erase the methanol result, not erase the deuterium result. It just means the final explanation is still open. And that is exactly why 3I Atlas is so valuable scientifically. It is forcing astronomers to rethink the chemistry of interstellar objects. So here's the payoff. Scientists care so much about the methanol because it tells them 3I Atlas may have formed in a cold, ice-rich environment with unusual organic chemistry. They care so much about the deuterium because it acts like a fingerprint of extreme cold and gives them one of the best clues yet about the object's birthplace. Together, those discoveries suggest 3I Atlas may be a preserved piece of an alien chemical environment, one unlike the environment that built our planets and comets. That is why this is not a small discovery. It is one of the clearest windows we have ever had into the chemistry of another planetary system. And maybe if future measurements keep lining up, into a much older part of the galaxy than we have ever sampled before. We are not just watching an interstellar object fly by, we are reading its history in molecules. And right now, that history is telling scientists that 3I Atlas came from somewhere very far from home, and very different from the world that made us. If this video got you thinking, subscribe to Space Aquarius so you do not miss what comes next. Leave a comment and tell me what are your thoughts on 3I Atlas. Check the link in the description for the full playlist about 3I Atlas. And share this with somebody who loves real space mysteries backed by real data.